Our discussion on circles has two parts. Today we will discuss area and circumference. The radius of a circle is the distance from the center of the circle to any point on the circle. The diameter of a circle is twice the radius. It is formed by a line segment that goes through the center of a circle. It's important to notice that there is a difference between just having a line segment that goes through a circle and a line segment that goes through the center of a circle. If a line segment doesn't go through the center, it's simply called a chord. Versus if it goes through the center, then it's called the diameter. Let's find the radius of these two circles. So in the first circle, I can see I have a diameter of 16 meters. To find the radius, I divide by 2, which gives me 8 meters. In the second circle, I have a diameter of 6.2 feet. If I divide that by 2, I have a radius of 3.1 feet. So I bothered to talk about going from the diameter to the radius because we often use radius in our calculations. The first calculation we'll talk about is circumference. Circumference is the distance around a circle. It can be given by the formula 2 pi r or pi d. So if you have the radius, you can use it. If you have the diameter, you may also use it. It is important to note that the circumference measures the outside of the circle versus the area that's going to measure the inside of a circle. So before we go on, let's say, well, what is pi? Pi is the ratio between the circumference and the diameter. If we were able to measure around the circle, the circumference, and then divide by the diameter, we should get something close to pi. So let's take this circle where I have dashes, and we can count up the dashes to kind of figure out what pi is close to. If you look at the diameter, you could bother and take the time to count, and the diameter has 16 dashes. The circumference has 50. If I divide 50 by 16, I'm just going to grab my calculator and put that in. 50 divided by 16, I get a value of 3.125. Generally, you kind of think of pi as about 3.14. What I have here is dashes versus a true calculation, right, where I didn't take out a ruler or I take out some kind of measuring tape to decide what's going on. So the better my measurement is, the better the value of pi is going to be. You do have pi on your calculator, so it is important that you take the time to find it. I put two calculators up. The first one's the TI-84 graphing calculator, and you can see in the first column there is a value for pi. It's over the up arrow. And the second one I put up is the TI-30X, and you can see the pi is in the first column and it has its own button. So let's use those buttons for pi, and let's find the circumference of the circle, and let's just go ahead and decide we're going to give 3 decimal places for all of these. So in the first one, to get the circumference, I'm going to do 2 times pi times 3.5. So I'm putting in 2 times pi times 3.5 into my calculator, and I got 21.991, and that's still centimeters. In the next one, I have a radius of 21 feet, so to get the circumference, I'm going to do 2 times pi times 21, which gives me 131.947 feet. In this circle, I have a diameter of 10 centimeters. Because I have the diameter, I'm not going to use 2 pi r, I'm going to use pi times d. This will be pi times 10. This is 31.416. This, again, centimeters. If you want to always use 2 pi r, that's absolutely fine. What you would want to do is first say the radius is 5. And then when you do your calculation, you would have 2 pi times 5, which will again, 2 and 5 is 10, which is my diameter. So either way works. Whatever you're comfortable with, that's what I would encourage you to do. Let's move on to the area. So the area, we already said, measures the inside of the circle, and our equation is going to be pi r squared. Let's stick to using 3 decimal places as we move on to the area. So the first example I have 4 centimeters. So my area is going to be pi times 4 squared. So I put that in my calculator. This gives me 50.265. Now that we're at area, we remember area is always squared. Right. In the next one, I have the diameter is 11 meters. I I also have a note. Pay attention whether I give you the diameter or the radius. So this time I have the diameter, and I first need to say, well, the radius would be 11/2, which is 5.5 meters. There's this difference between circumference, where I could do 2 pi r or pi d, and the area where I have to use pi r squared. So I'm really encouraging you to immediately switch over to the radius if I give you the diameter when you're looking for area. Here my area will be pi times 5.5 squared. I get an area that's 95.033 meters squared. In this question, we want to find the radius of a circle with a circumference equal to 15 inches. Now remember, circumference is 2 pi r. So we know our circumference is 15 inches, and that's equal to 2 pi r. You want to divide both sides by 2 pi, so we're isolating the radius. When you put this in your calculator, it's going to be really important that you put parentheses around the 2 pi. So I have 15 over 2 pi gives me 2.387. Remember, it was in inches, so this says my radius is also in inches. Let's find the radius of a circle with an area equal to 35 inches squared. We know area is equal to pi r squared. That says 35 is pi r squared. To get r by itself, I need to divide by pi. And then to get r, I need to take the square root of both sides. When you're taking the square root, you're taking the square root of 35 over pi. So if necessary, you may need to put parentheses around the 35 divided by pi in your calculator. This says that I have 3.338, and remember it's inches, so this is my radius. So let's think about some application to this. Speedometers are designed to gauge the speed of your car based on the tires it was originally manufactured with. So you kind of think of the tires and speedometer as a matched set. If you change the size of the tire, you've changed the accuracy of your speedometer. Since the speedometer is paired to the tire size, the speedometer is in effect using circumference of the tire to calculate the distance being covered by every rotation. If you get smaller tires, or if the tires are underfilled, then you will be going slower than your speedometer indicates. This is because a tire with a smaller radius has a smaller circumference and therefore goes a shorter distance when it rotates. If you get larger tires, you will be going faster than your speedometer indicates. A tire with a larger radius has a larger circumference. Every time the tire rotates, you cover more distance than your speedometer expects. So you think you're doing 55 miles an hour in a 45-mile-an-hour zone, when in actuality, you're really going 55 miles an hour. That could be a problem. So let's say we have 33-inch diameter tires, and we want to increase them to 37-inch diameter tires. Let's look at the circumference of the 33-inch diameter tire first. So I have circumference is 2 pi r, or pi times d. Since I'm given the diameter, let's just go ahead and use the pi times d. So 33 times pi says this circumference is 103.672, and this would still be in inches. Let's say we have 37-inch tires. The diameter would be pi times 37. This gives me 116.239 inches. So you can see this difference between 103 and 116, and that's on every rotation. Let's see how the circumference affects the speed that's happening when we change the tire size. So we can look at the two circumferences we found for the tires, the 33-inch versus the 37-inch. And we can divide the two to see what ratio, how much have we increased it by going from the 33 to the 37. So I'm taking the 116.239, I'm dividing by 103.673, and I get 1.121. So let's say we were going 50 miles an hour, and we multiply the 50 times 1.121, which is that increase in size, which says we're now going 56.05 miles per hour. So a big difference between what your car would be thinking unless you get your car recalibrated when you change the tire size. Backup plan, you can always use your GPS. It'll show you how fast you're going.